Okay, so today is test review for the upcoming tests on hyperbolas and parabolas. So pause the video here and try these problems. Okay, here's all of the answers. We actually skipped number 2, so I'm going to white that one out. Okay, so for number 1, it's a circle, so I'm going to do x minus the center point plus y minus the center point equals the radius squared. So we got this equation. For 3, I'm going to draw myself a little picture to help. So here's the vertex, and the focus is at 7, 1, negative 1. So because the parabola has to go around the focus, now it's going to go this way, so that's the setup of y squared equals 4px. So we're going to put in the vertex point, so it's going to be y plus 1 and x minus 4. The last piece I'm missing is p. P is the length from the vertex to the focus. So to go from 4 to 7, p is 3. So when we plug that in here, where I get my 12 from. And now for 4, I'm going to again draw myself a little picture. Okay, now I have some more room. Here's 8. These are both foci. And then the vertices are at 3 and 4. Okay, so to find the center, it's the middle of the foci or the middle of the vertices. So I'm going to use the vertices. They're closer together. So that's going to be 2. Then I'm going to do 3 plus 4 divided by 2. And 7 divided by 2, that's the 3.5 here. Because this all lines up vertical, I know the y is the positive variable. So now I need a squared and b squared. A squared is the length from the center to the vertex. So the length from 3 to 3.5 is 1/2, which makes a squared 1/4. Here they wrote the answer as a decimal. That's fine if you choose to do that. And then b squared we have to calculate. C is the length from the center to the focus. So C is, so from 3.5 to 8, excuse me, so to calculate that, we could subtract, get 4.5. So then we have to do C squared equals A squared plus B squared. By calculating that, that's where this 20 comes from. Okay, so moving along to classifying the conic sections. When I look at the squared terms, my coefficients are different, and they're added, so that's what makes it an ellipse. Here, my coefficients are exactly the same. They're both negative, so that means it's a circle because they're identical. Parabola only has one squared term. There's no x squareds. And then for 6, one of the squareds, for 8, one of the squared terms has a negative coefficient where the other is positive, making it a hyperbola. Okay, so finding the points of intersection. For number 9, I'm going to use the substitution method because we already have y equals. So I'm going to substitute in what y equals for the y variable in the first equation. Distribute this negative. Find my like terms. And now I have to factor. So I'm going to split the middle. 3 times -2 is -6. So what multiplies to -6 that adds to 1? We're going to use -2 and 3. Factor out the greatest common factor. Regroup it. We get x is -1 and +2/3. So for each x value, I need a y value. It's much easiest to use the second equation to find the y value than it is to use the first one. So I'm going to plug -1 in for x here. So we get 5 plus 4, which is 9. We're also going to then plug in 2/3. Okay, so that's -10/3 plus 4. But I want it as a denominator of 3, so I can add these together and get 2/3 as my y value. Okay, moving on to 10. For 10, I'm going to use the combination method, and I see that these are already opposite coefficients, so I'm going to add them together. Get 2y squared minus 12y plus 16. Ooh, there's a greatest common factor of 2 we can factor out. I can factor the remaining polynomial, or trinomial, excuse me. And we get y is 4 and 2. Okay, so that means I now need my x coordinates for the corresponding y coordinates. Which equation should I use? Let's see, we're solving for x. So I think I'd like to substitute into the bottom one since both of my square terms are positive. So I'm going to plug in 2 for y. Combining my like terms here, and I'm going to write it in standard form. Now we can factor. We get x is 2. And we have to repeat for plugging in the 4. I'm going to use the same equation, plugging in 4 for every y. Let's see, 16 and 12 is 28, minus 4 is 4 again. Hey, it's the same quadratic, so I know the answer is going to be 2. There's our 2 intersection points. All right, one more with number 11. I notice how my x squareds have the same number as a coefficient, but they're the same sign. So I'm going to multiply this equation by a negative, and now add them together. To then solve. Let's see, can we factor out 17 from 68? We can. It's 4. So we can factor out the greatest common factor. Factor our remaining trinomial. We get y is -2. Oops. So I need to find the x value when y is -2. And let's see, which I definitely want to use the first one. It has less negatives. It has smaller coefficient numbers here. So we get x squared plus -2 squared squared times -2 minus 12. So that's +4 minus 8. That's supposed to be 12 minus 12. So that's x squared. Oh, that's how we're going to get two x values, because we're going to have to square root both sides. Oh, or it can factor. This factors x minus 4, x plus 4. That's how we get plus or minus 4 as an answer. Or if you don't want to factor it, you could have added 16 to the right. And when you square both sides, you need plus or minus 4. Okay, so in class we're going to do a bunch of ActiVote questions. So for each question, pause the video, see if you can get your answer, and then resume, and I will show my work and reveal the answer. It is E. Here's how we get it. The vertices are at 3, 5, 3, -1. So that means the center is in between. So it's going to be at 3, 5 plus -1 divided by 2 is 2. So the y value has to be with a 2. All of them are here. Okay. So then it lines up vertical, so that means the y variables first. And the only thing that's different between all these is my b squared. So let's see. I'm going to have a and c. So from 5 to 2, that's a value of 3 for a. And c is from 7 to 2, that's a value of 5. So 25 equals 9 plus b squared. And when you subtract, you get 16, which is why our answer is D. Okay, so for this one, my coefficients are different. It's an ellipse. Which equation is graphed? I'm going to eliminate the y squared since this is a vertical parabola, and I'm going to eliminate c because that's positive. It has to be D. This negative opening down. Okay, try this problem. Answer is D. It's nice that the center is at 0, 0. Since it's an ellipse, A is 9, B is 4, and since the vertex is in the y coordinate, A goes underneath the y. So that's 81 underneath the y, b squared is under the x, and that's how we get our answer for D. Okay, so for this one, try it. Oh, here's your answer, E. The coefficient is only on the non-squared, so I'm going to divide both sides by 2. X squared equals -60y. So 4p is 60, which means p is 15. And since it's negative, we go down to get to the focus. What is the intersection of these graphs? You should get B as your answer. This is a substitution problem since this one already has y isolated. do not distribute the square. You have to multiply 3x minus 7 times 3x minus 7. So we get 10x squared minus 42x. And I'm going to subtract the 41 over while we're at it. Oh. Okay. We can split the middle, or we could do quadratic formula. You pick what you'd like best. I know, see that all the answers, none of them are decimals, so I know it will factor. Let's see, 10 times 8 is 80. What multiplies to 80 that adds to 42? So I'm going to list out my choices. We've got 2 and 40. No, that's not going to work. Because oh yes, that is. Okay, because they're both going to be negative. So we have 10x squared minus 2x minus 40x plus 8. Factor out the greatest common factor. I get 8. X is 4 or 1/5. They have both as answer choices. No, so thankfully only B is my possible choice because it's the only one with that x value. What conic is represented? There's only one squared term. It's a parabola. See, was I right? Okay. What is the directrix? Should get P as your answer. 4P equals 24. So P is 6. Because the x is not squared, it's going to go this way. The directrix is over here at x equals negative 6. You must have the x equals part. It is a vertical line. Okay, which graph is this? Well, off the bat, I'm going to eliminate E. It's a hyperbola. I'm going to open in the y direction, so I'm going to eliminate these two. And the y is up 5, so it has to be C. All right, another intersection. I'm going to line these up. That does not look like a nice elimination. I mean, it works as elimination. So I'm going to multiply this one by 2, this one by 25. You could do this with substitution if you isolated the y here, but I didn't want to have to then square it here, which is why I decided to go this route. Doesn't look like it's going to be much better, though. So when we add these together, we get 72y squared plus 25y minus 1,675. I don't know if you factor that. Let's see what the answer is. Those are really big numbers. We won't do that to you on the test. -5. Your test is not calculator. I promise the numbers won't look like this. How many points of intersection? Okay, we have a circle and an ellipse. So there could be a few different possibilities. In this case, the answer is none. So let's see. If x squared plus y squared, I'm going to set up this one for elimination. I'm going to multiply the top one by -2. When we add them together, we get 2y squared equals negative. That's a problem. 5. So y squared is going to be -5/2, and you can't have imaginary intersection values. When you square root this negative, that's why it's. Okay, now this is your homework. To study for the test, this page, just as a heads up, 36 and 37 are not very lovely problems. 38 is wonderful. Recommend focusing on 38. All of the answers are in the flip chart that is posted on Edline.